Welcome back, everyone. Here is your instructor, Professor Rodriguez, with the ladder logic programming class. We have come very far, and we're not there yet, but we're gonna be able to arrive. What I have here for lesson 13, 14, and 15 will be heavily loaded with lots of programming demonstrations, lots of programming activities, lots of programming analysis, and so on and so forth. In this lesson, we are looking at bit level ladder logic programming instructions. And these are some of the most useful commands that you could possibly use in ladder logic programming. And they include, but are not limited to, the XIC, examine if close, XIO, examine if open, OTE, output energize, OTL, output latch, OTU, output on latch, and OSR, one-shot rising. Additionally, we're going to be covering what we explained before, and that's the basic logic, computer logic configuration that applies to ladder logic programming. And here actually I have this table once again where we have the logic symbol, the truth table, and the ladder diagram or ladder logic equivalent. And so we're going to explain them with the real software, and then we're going to go ahead and set it up so you can see how they work. So let's go ahead and look at the basic instructions as we deploy the software. So I have the software here somewhere, and by this time you should be familiar with the two options of software we're using. One is the RS Links Classic with the RS Logix with hardware, with this piece of equipment, and the other one is not using the hardware but adding to the two previous software pieces the RS Logic Emulate. Now if you're trying to use them both at the same time, you're going to have conflict, so they don't work. One or the other have to be done. And in this particular instance, I want to use my hardware here. Once again, if you're interested in the hardware itself, the PLC controller, just let me know and we can talk. It's an investment. It's not inexpensive, but it's an investment. If you determine you want to do a lot of prototyping, development of PLC design, you probably want to have your own box. My next course will be how to build this controller so you can have your own controller for yourself. Okay, so let's go ahead and launch. Here I'm going to launch the RS Links, and with that I just want to verify that I'm going to use the RS-232. So it looks like I have here the controller, but the driver itself is not working too well. So we're going to configure that. We're going to configure drivers. I'm going to stop that, and I want to get rid of this one for the moment, and I want to bring up the RS-232, which is the one that I know that works with my system. Select micro, and I believe it's port number 3. I'm going to auto configure, and I should successfully be able to get auto configuration successful. We're good, and I'm going to close that. I'm going to check back here and know that the controller and PLC are talking to each other. Nice. All right. Next, I will call out the RS Logix, and I'm going to select a new program. I'm going to select micrologix. I'm going to reselect here the AB_DF1-1, which is the driver that I just selected for my controller. And here is my programming screen. You're familiar with that. I showed you this one previously. And with this, I'm going to start programming. So let's go back and take a look to the basic instructions. Here is the user and bit level programming instructions. All right, and there's a difference here between user and bit level. User are normal instructions. Bit level, it means that you're using internal computer memory to make things happen, not necessarily using inputs and outputs that are hardware based, but that are just basically computer based. And so I will do a little demo here using the user, and I'm going to put a couple of instructions. I'm going to use a examine if close instruction, and I'm going to use an output energize instruction, OTE. All right, one other way you can know where these instructions are is if you go view and you select instructions palette. That comes on here, and it's nice because you have the ability to also use this palette to bring up the instructions that you want, if you know what you want, right? So that's one other way you can do that. Okay, I'm gonna get rid of that instruction. So here I have an examine if close and an output energize instruction. So with the examine if close, as we explained previously, the controller is looking for an on signal, right? Something that will be closed. And so I'm gonna bring my data output table and data input table, and that is what you need to use in order to address each of the elements that are going to be on your ladder logic program. In other words, there's always a need to address, and addresses are the ways to label what each of the elements or IOs or inputs and outputs on the program are. The labeling is very important because it tells the controller itself where in the physical points of contacts or terminals of the controller that component is connected. So by default, I know that my start, right, it's input number 1 on this controller. So because input number 1, I'm going to address this examine if close instruction with input number 1. So I'm going to click input 1 right out of the input table. I'm going to hold it down and drag it over and release it when it comes green, right? Likewise, I know that I have 4 outputs on my controller, and I can use any one of those 4 outputs, 0 through 3, right? 0, 1, 2, 3. And with that, you can energize the program. I'm going to use output 1, which is the green light. Hold it down and drag it over. So I have now an examine if close instruction and an output energize, right? Correct. Now, in addition to this, there's a couple of things I want to mention here. Is the need to document. There's a need to document, right? There's a need to document this programs. And the way you document this program is, one, you can right click and there and say edit title, and you can say my first PLC program. All right, and we are done with that. It's kind of a little big table. Should be able to minimize it. It won't let me. Okay, anyways, that is my first PLC program. You can also edit the components, and you do edit description, and this is going to be the input 1, which is equals to green PV or push button, right? So documenting is very important. This is going to be output 1. I'm going to document the edit. So output 1, which is really the green light. And I'm labeling it this way because this controller has already been wired that way, right? So that with this, let me explain how address works while I'm here, okay? The way addresses work for this particular controller is that I is the designation for input. 0 is the designation for the module. In this case, it's a single compact PLC, and 1 is the designation for the point of contact or terminal, right? So in this case, is an input, is the single module 1 or processor, and then it is point of contact or terminal 1. And for the output, the way this address is, O stands for output. 0 again is a compact controller. If we had a modular controller, this number right here after the semicolon will change. Right, after the colon will change. And once again, the last number here, the digit, designates the point of contact or the terminal on the controller. All right, so in this case, again, is output 0, contact or terminal 1, right? And nothing that you have to worry because this is already being wired that way. In other words, green light is wired terminal 1 of the controller. So we have then a program right here. I'm going to put my bar up there. And this guy is ready to be tested. So you can minimize, maximize, do whatever you want to do. See the arrows? And this program is ready to be tested out. And the next thing you want to do is you want to, of course, download. This is looking for a signal to be on in order to energize the output. All right, so I'm going to go ahead and download it. And it asks me for a name. And I'm going to call this ladder program 1. All right, and now it's asking me whether I want to download that. And I say yes. Asking me if I'm going to put the system in run mode. I say yes. And it's downloading that onto the controller. So in this case, we're working with the hardware. And now I'm going to go back to run mode and then go online. Right? So now we have the system online. Every time you see this guy, this icon turning around, it means that we're online. We have our controller connected to the or laptop connected to the controller, right? So here I go again. I'm going to press start, and as long as I hold it, the system is energized and the output is energized, right? So that is an examine if close instruction, right? So I'm going to go offline and I will add a second run. Here I go on top, and I'm going to add an examine if open instruction. And I will add another output energize. And this time I will bring back again my output. I'm going to close this out, okay? And my input table. And they're both here needed so we can properly address. Once again, I'm going to use input 0 because I do know that my input 0 on my controller is a normally closed contact. All right. Actually, I could use either one, right? As a matter of fact, I can actually use the same input as this one. I'm gonna do that intentionally, right? It could be a different, but I'm gonna use the same input. And so for the output, I definitely want to use a different output. So I'm gonna use the yellow light, which is connected to my output 2. How do I know that? Well, it's been wired that way. This particular controller has only 4 output terminals. And so blue light is connected to output terminal 0, green light to output terminal 1, yellow light to output terminal 2, and the red light to output terminal 3. So I'm going to label this one here. So in this case, the green button is accomplishing 2 functions, right? And we're going to see how this works in a little bit here. So we're going to say this is output 2, and this is going to be the yellow. So we have documented our program a little bit. And I'm going to go back and download. All right. Put it in run mode. And we're just doing that. Download it and put it in run mode. I'm going to put it back and run again. And notice that right when the system is downloaded, my green yellow is on. And the reason being is we're using an additional instruction here, which is the examine if close instruction. This instruction is looking for a signal present that will open up that instruction. And notice how this is going to work, because the green light, my input 1, is fulfilling 2 functions. It will do exactly what it's supposed to do. When I press the green light, the green button, it will energize this one, which is looking for an examine if close instruction, and it will de-energize this one, which is looking for an examine if open instruction. All right, so let's see what it happens. There you go. So as I press this input, which is looking for an on signal, it also performs the function on this one. As I act upon it, it opens up the circuit, right? So this is normally open, you can say, examine if closed, and this is normally closed, examine if open. And it's doing what it's supposed to be doing. Right? We're controlling basically 2 different outputs with the same input. Kind of interesting, isn't it? So there we have what we call an examine if closed, an examine if open, and an output energized. So we have studied the first 2 instructions: examine if closed, examine if open, output energized. Now I'm going to go back and demonstrate the output latch and output unlatch. All right, and so I'm gonna go back out of line, and what I want to do here is I want to modify this program, and the way I'm gonna modify this program is I will use I'm gonna keep these two outputs, green light and yellow light, but for this particular one I need to examine if clause instruction. This one's gonna go, so I click on it and I hit delete, so that's going. I need two different inputs that will trigger the same output. As a matter of fact, I'm gonna change these two guys too because I need to demonstrate what we call the latch unlatch instruction. And the way the latch unlatch works is that it looks for a trigger signal. I'm gonna remove this one. I'm gonna remove this one. It looks for a trigger signal to energize the output, and it looks for another signal to de-energize the output. In other words, the outputs for the latch unlatch have to be addressed with the same address because you're controlling the same output. So in this case, I like to use the red light, which is connected to terminal number 3. So I'm gonna hold and drag terminal 3. I'm gonna address the latch, and I will also address the unlatch. This is the condition for latch and unlatch. They always have to have the same address because you're latching and unlatching, in other words, energizing and de-energizing the same output component or the same output device. Okay, so there is, I can label this. I'm gonna edit description, and this is gonna be output, what is it, 3, which is equals to the red light, red pilot light, red PL. And notice that both of them are labeled because they are addressed with the same address, which means we refer to the same output element that is connected to the same terminal. But then I need to use two different kinds of inputs to control that. So I'm gonna keep the input 1, and I will add input 2. All right, so for this one I'm going to use input 2, and input 2 is exactly what that is, toggle switch. Input 2 is a toggle switch, and so here again we're controlling the same output with a special instruction called the latch unlatch. And what happens here is input 1 latches it, and input 2 unlatches it. All right, so we're gonna go and download that. All right, and once again we're using the actual hardware right now, the controller, to do what we're doing here. I will also demonstrate to you how you can do this without the hardware. Okay, go online, and here we go. Press 1, and the system latches up. In other words, it's energized, output latch, and with 2 the system is unlatched. All right, one more time. Input 1 latches it, and input 2 unlatches it. So we now have gone over, let's go back, XIC, XIO, OTE, output latch, output unlatch. And so we got one more instruction. This is what we call one-shot rising, which is another way to trigger a signal. Very similar to what we have here. But essentially what it is an output element that will respond to a trigger signal. All right, let's see how we can do this. How's our time? It's getting pretty big. So that's the last instruction we're doing. And I'm going to basically modify here my thing. And I'm going to still keep that. And I'm going to add an output instruction. I'm going to use the same address. I want to keep the same output and get rid of this. And now what we're going to see here is I'm going to change this to a one OSR, and this OSR will have that address. And so here I have a one-shot rising instruction. Essentially what we have is there's only one moment when this output is energized, and that's at the rising or going up of the signal of that particular input. Notice that only one instant that the output is it's energized, and that's the reason why it's called one-shot rising. As the signal is going up from 0 to 1, or from off to on, or from false to true, the output is energized, right? Just at that very moment. So anyways, the video is getting long. I think that we're gonna have to add more content, but this was the review of the concepts on XIC, XIO, OTE, OTL, OTU, and one-shot rising. I will see you in another video that we're gonna do for this part, so we can demonstrate the actual logic function uh, and the equivalent of the AND, OR, XOR, NAND, NOR, and exclusive NOR, so that we can see how that plays out in ladder logic programming, right? So I will be seeing you in another video in just a little bit.